A warm welcome to the first module of Parallel and Intersecting Line series. Today, we will explore the fundamentals of lines that cross paths and those that run alongside each other forever. After this module, you will be able to analyze relationship between any given pair of lines and establish if the lines are parallel or intersecting. But before we move on, let us quickly recall the definition of line by answering this question. Which of these is not a characteristic of a line? First, it is made up of infinite points. Second, it is a one-dimensional figure that goes indefinitely in both directions. Or the third one, it has fixed width and depth. You may pause the video to match your learning pace. I am sure your answer is correct. A line is made up of infinite points. It is a one-dimensional figure that goes indefinitely in both directions. It has negligible depth or width. So our option will be the third one.
Observe the two lines on the screen. See how some lines might not cross or meet each other currently, but when we extend or move them around, they do intersect. But then there are certain lines which will never meet or cross each other no matter how far we extend them. They will always run alongside each other. We will investigate different scenarios to answer these questions. As of now, we can conclude lines either cross each other or they will never meet or cross. Let us explore both the options one by one. So the lines that move. Observe the lines on the screen. Are these lines crossing each other? They are, and the point at which they intersect or meet is labeled as O. This point is called the point of intersection, and these lines are called intersecting lines. This brings us to another question. Can two straight lines intersect at more than one point? Observe how the position of this line is getting changed from P to N to Q. What is your observation? No matter where the lines are moved, the point of intersection remains the same. So what conclusion can we draw from this observation? Two straight lines can always intersect only and only at one point. So now can you define intersecting lines? Intersecting lines are the lines that cross each other, and they cross each other at a single point. This point is called the point of intersection, and these lines are intersecting lines, the ones you are seeing on the side of the screen. If we tie two toothpicks with a rubber band and place them on a protector or a page with degree markings, we can explore a special case of intersecting lines. Observe the demonstration on screen. You can see the lines are crossing each other at a 90-degree angle, forming four right angles at the point of intersection. This is a special case of intersecting lines. Let's explore. When two lines intersect each other at 90 degrees, they are called perpendicular lines. And at the point of intersection, four right angles are getting formed. So you can see AB and CD are intersecting at 90 degrees, making them perpendicular to each other. This can be represented using a symbol which is intuitive to the perpendicular lines. Now that we have some hold on intersecting lines, let us explore the second scenario where the lines never meet. Look at the two lines on the screen and specifically observe what is different in their interaction. No matter how much we extend them, they still will never meet, and the distance between them will always remain the same. Such lines are called parallel lines. Let us name these lines L1 and L2. The lines that never intersect, no matter how far they are extended, are called parallel lines, and they can be mathematically represented using a very intuitive symbol. So this symbol represents L1 is parallel to L2. But is that all there is to defining parallel lines or intersecting lines for that matter? There is a crucial aspect to consider. Parallel lines or intersecting lines must lie in the same plane. But what does it mean for the lines to be in the same plane? Let's explore. Imagine your friends draw a line on the classboard and you draw a line in your notebook. Can you compare these two lines? Not really. They are in different planes. But why can't we compare them? Because they can be easily manipulated. So for the lines to be parallel or intersecting, they need to be in the same plane. But then what are these lines called which belong to different planes? They are called skew lines. And you will come across this geometrical concept very often while dealing with line interactions. This brings us to redefining parallel and intersecting lines. You may pause the video and write your own definition. So in conclusion, parallel lines are the lines that lie in the same plane but never intersect no matter how far they are extended. While intersecting lines are the lines that cross or meet at a single point in a plane. But can we deeply understand parallel lines without a mention of intersecting lines? Observe the interaction on the screen. See how line L1 and L2 are parallel, but M is intersecting them. What are such lines called? They are called the transversals. A transversal, that means, is a line that cuts across two or more lines in the same plane. So by this definition, can I call EF transversal to AB and CD? What's your take on it? Is line EF a transversal since it is also intersecting AB and CD at O? No, this line is not a transversal because it is only intersecting AB and CD at a single point O. For a line to be transversal, it must intersect at more than one point, separate points of intersection for each line. Only then a line can be considered a transversal. So let us explore. A transversal line is a line that intersects two or more other lines at distinct points. And these lines can either be parallel, they can even be non-parallel. But the important point is that there has to be distinct points of interaction or intersection. So line M is a transversal to line L1 and line L2. Why? Because it is having two separate points of intersection. While EF is not a transversal because it is intersecting at only one point of intersection. Now that we have some hold on the concept, let us quickly recap. Can two lines in different planes be parallel or perpendicular? You may pause the video to match your learning pace. No, we cannot compare two lines in different planes. They are skew lines. Which of the following is not a characteristic of parallel lines? Parallel lines are always equidistant from each other. They do not meet at any common point. They can be extended indefinitely in both directions. Parallel lines may cross each other at 90 degrees. So what's your answer? See, parallel lines are always equidistant. Equidistance means maintaining equal distance from each other. They do not meet because they are at a distance from each other. They can be extended indefinitely. That is the definition of any line. So we are left with only one option. Parallel lines may never cross each other. So 90 degrees out of question. If a line A is parallel to line B and line B is parallel to line C, what can be said about line A and line C? If you keep in mind the concept of equidistant, you will know that A and B are at equal distance, they will never meet, and same goes for B and C. So the correct option is they are parallel to each other. So this brings us to a conclusion. A pair or set of lines may never meet or cross each other, no matter how much we extend them. And these lines are called parallel lines. Whereas there are lines which will cross each other or they already are meeting. They might meet when they are extended. Such lines are called intersecting lines. For a mastery in naming of angles and identifying them, join me in the next module. Until then, keep learning, keep practicing, and stay curious.
Stay in the video till the end to dive into the rapid fire round and show off your math skills. I'm now leaving you with questions that will challenge your understanding. Put your pen to paper, music on or mute, whatever helps you focus. Take your time and let your math progress shine and reflect.